Hello children, today we are going to study about the squares. Okay, you are already familiar with the concept of squares. Tell me, what are the squares? Suppose I have any number x. I multiply that number x by itself. Then I'll say that this is x square. I'll write it as x square. Here x is the base and 2 is called as index or the power. Now take for example 4 square. What is 4 square? 4 times 4. 4 into 4, that is 16. Now you should be familiar with, or rather you should keep in mind, the squares of first 10 natural numbers. 1 square, that is 1 into 1, which is 1 itself. 2 square, 2 into 2, 2 twos are 4. 3 square, 3 into 3, that is 9. 4 square, 4 fours are 16. 5 square, 5 fives are 25. 6 square, 6 six are 36. 7 square, 7 sevens are 49. 8 square, 8 eights are 64. 9 square, tell me what will be 9 square? Yes, 9 nines are, that is 81. And finally 10 square, 10 tens are 100. So just keep these squares in mind. That will help you out for the further calculations. Now, today I'll teach you one method to find out the squares. That will be the base method. When you did the Nikhilam multiplication, I had taught you what are the standard bases. Tell me, what are the standard bases? Any number, yes, that is some power of 10, like 10, 100, 1000, and so on. These are called as the standard bases. Okay, and we are going to use this standard basis for calculating the squares. So let us take some examples. First one, 14 square. Now for 14 square, I'll take the standard base as 10 because the number is near 10, and also you can see that here the tens place is 1. That means the standard base is 10. Now what are our steps? I'll make a partition here. On the right hand side of the partition, I'll square the units place. 4 square is 16. And on the left hand side of the partition, to the number 14, I'll add the number excess over the base, that is 4, and that is nothing but the units place. So I'll add here 14 plus 4 is 18. And now since the base is 10, I'll keep only one digit on the right hand side of the partition. Remaining excess digits I'm going to carry forward to the left side. So 18 plus 1 is 19 and 6, and hence 14 square is 1 196. Let us take one more problem. Say I want to find out 18 square. Just write out in your book and then we'll discuss using the same method. Try to find out this. Yes. So what will be the standard base for this? Obviously, yes, it is 10. So what are your steps? Make a partition. On the right hand side of the partition, what will you do? You will square the units place. 8 square, that is 64. On the left hand side, what will you do? The number 18. To that you add the excess number over the base. So excess number is 8, that is the units place here. 18 plus 8, 26. So 26 on the left of the partition, 64 on the right of the partition, and since the standard base we are taken as 10 here, I will keep only one digit on the right side of the partition and carry forward this extra digit. 26 plus 6, that is 32, which means 18 square is 324. Okay. I'm giving you one more problem to do. Try to find out. Say 17 square by itself, by yourself. Try to find out 17 square by yourself. So standard base is 10. So on the right hand side, square 7, that is 49. On the left hand side, 17 plus excess number over the base is 7. 17 plus 7, 24. So 24 on the left, 49 on the right. Since the base is 10, what will you do? Keep only one digit on the right. Excess digit you carry forward. 24 plus 4, that is 28. And hence 17 square is 289. Okay. Yeah. So these are some of the problems where we are using the standard base 10. But suppose the base is not standard, then what will you do? Let us take some problems here. So take the first problem. Let us find out the square of, say, 35. Try to find out the square of 35. Now, for 35, the standard base, since the number is of 2 digits, I'll take the standard base as 10. But now as you can see here, the tens place is 3, that is 30, and hence I'll take one more base here, that is the working base. Working base, I'll take it as 30, and that is 3 times the standard base, 10. Okay, now we are going to follow the same steps here. On the right side, I will take 5 square, that is 25. On the left side of the partition, 35 plus the excess number over the working base, that is 5. So 35 plus 5, that is 40. Now, here I'll take one more step. Because the working base is 3 times standard base, I'm going to multiply this 40 by 3, that is 120. So on the left hand side of the partition 120, on the right hand side of the partition 25, and since the standard base is 10, keep only one digit on the right, carry forward the extra digit, that is 1, 2, 2. 120 plus 2, 122 and 5, which gives 35 square adds 1225. Okay. Okay, let us take one more problem here. Say 26 square. And now you will tell me what will be the standard base for this and what will be the working base for this. Try to answer me. Yes. What is the standard base? Obviously, for the 2-digit numbers, the standard base will take it as 10, correct? Now tell me, what will be the working base? Here the tens place is 2. That means what should be the working base? 20. And 20 is how many times the standard base? 2 into 10. So again make a partition. On the right hand side of the partition, square 6, that is 36. On the left, what will you do? With 26, add the excess number over the working base, that is 6, correct? So what is 26 plus 6, tell me? It is, yes, 32. Now what is your next step? The working base is 2 times the standard base. So what should you do? Multiply 32 by 2. 32 times 2, that is 64. And on the other side, this is 36. So now, since the standard base is 10, what should I do? Keep only 6 on the right side and carry forward 3. What is 64 plus 3? 67. And hence, you get 26 square as 676. Okay, let us try some more problems here. Okay, so let us find the square of 64. 64 the whole square. Okay, tell me, for 64 square, what will be the standard base? Standard base is 10 here, 2-digit number. Now, tell me what is the working base? Yes, because the tens place is 6. What will be the working base? 60. And 60 is 6 times 10. So, what is your next step here? On the right hand side of the partition, square 4. 4 square is 16. On the left hand side of the partition, 64 plus the excess number over the working base, that is 4. 64 plus 4, that is 68. Now, the working base is 6 times the standard base. So, multiply 68 by 6. How much is that? 68 multiplied by 6 is 408. On the right hand side of the partition, this is 16. And since the standard base is 10, what will you do? You'll carry forward 1. Isn't it? So 408 plus 1, that is 409, and 6 is remaining here. So what will be 64 square? It will be 4096. Okay, try to find out 95 square in a similar way. Yes, tell me what will be the standard base in this case. What is the standard base? It is 10 ohm, isn't it? Working base, since the tens place is 9, working base is 90, and 90 is what? 9 times 10. Okay, so tell me the first step student. Yes, on the right hand side of the partition, what I'll do? Square 5. So first step is on the right hand side, 5 square, that is 25. What is the second step? 95 and the excess number over the working base. Working base is 90, so excess number is 5. Add 95 plus 5, that is 100. Now, what is the next step? Tell me. Because the working base is 9 times the standard base, what should I do? I'll multiply 100 by 9. That is 900. So 900 on the left side of the partition. 25 is on the right hand side of the partition. So now what to do? Because the standard base is 10, the excess number, only keep 5 on this side. The excess number 2 will carry forward on the left side. So 900 plus 2, that is 902, which gives me 95 square as 9025. Okay, is that okay with you? How to find out the squares of 2-digit numbers using the base method. Now, let us extend this method for the 3-digit numbers. So, let us find 314 the whole square. So what will be the standard base for 314? Since it is a 3-digit number, I will take the standard base as 100. Okay, and working base. Now since the hundreds place is 3, working base is 300, which is 3 times 100, the standard base. Now I'm going to follow almost the same steps, but here keep it in mind that standard base is 100, which has 2 zeros. So I'll take right hand side 2 digits on the right hand side of the partition, that is 14, because 100 has 2 zeros. So take 14 and square it. Now to find out the 14 square, I will use base 10 method, and already we have found it. 14 square is 196. On the left hand side 314, and the excess number over the working base, that is 300. So 14 I will write here. See, 314 plus 14, that is 328. Now since the working base is 3 times the standard base, I'll multiply 328 by 3. And 328 multiplied by 3 is 984. Okay, so on the left hand side of the partition 984, on the right hand side of the partition 916. Now since the standard base is 100 and 100 has 2 zeros, how many digits I will keep on the right hand side? 2 digits, and 1 digit I will carry forward. 984 plus 1, 985, and 96 remains here, which gives me 98,596. So 314 square is 98,596. Just go through all the steps, check whether you are understanding all of them. Yes. Okay, so to make this concept more clear, let us take one more problem. Let us calculate 518. 518 the whole square. So here again, the standard base will be, since it is a 3-digit number, the standard base will take it as 100. Working base. Now the hundreds place is 5. So working base is 500, which is how many times the standard base? 5 times 100. 5 times the standard base. So make a partition. On the right hand side of the partition, square 18, and already we have found the 18 square by using base 10 method. 18 square is 324. Obviously you can find this 18 square on the side by using the base 10 method, but since already we have got it, I am using it here. Then what is the next step? 518, the excess number over the working base, that is 18. I am going to add here 518 plus 18, that is 536. Now since the working base is 5 times, I will multiply 536 by 5. So 536 by 5, that is 2680. So on the left side of the partition, write 2 8680, right hand side 324, 324. Now since the standard base is 100, keep 2 digits on the right, carry forward this 3. So this will become 2683 and this 24. So finally you'll get 518 square adds 2, 6, 8, 3, 2, 4. 268,324. That is 518 square. Let us just take one more problem. 935 the whole square. So what is the standard base here? Again 100. And working base, since the hundreds place is 9, working base is 900, which is 9 times 100. So again make the partition. On the right side of the partition, write 2 digits 35, square it. And already we have found out 35 square, that is 1225. On the left side of the partition, what will you do? 935 and the excess number over the working base, that is 35. So 935 plus 35, that is 970. Now, since the working base is 9 times the standard base, I'll multiply 970 by 9. How much is that? 8,730. Okay. So, on the left of the partition, 8,730. On the right of the partition, 1,225. And since the standard base is 100, I'll keep 25 on this side and carry forward the remaining digits, that is 12 I'll carry forward. So 8,730 plus 12, that is 8,742. So finally 935 the whole square is 874,225. That is 874,225. Just go through this, check whether you are understanding all the steps properly. Yes, so this is how, by using the base method, we can find out the squares of 2 or 3 digit numbers. Okay, so enjoy the day, children. We'll meet in the next class and I'll teach you something called as the formula method of finding the squares. See you. Enjoy the day.